Calculus. It's time to do our weekend edition. So sometime after class on Friday, you will watch the video about the derivative of a product. And we've been wondering about that. So let's see how it works. So one way I can symbolize that is the d, and I'll put a product. One function is f of x, the other is g of x. I put them together by multiplication, and I say d dx. So the derivative of a product with respect to x. That just says the variable in the problem is x. So I'm going to look for the derivative of a product. Now we've dealt with the derivative of a sum. So we've dealt with this, the derivative of a product. The derivative of a sum, and we have found it to be the sum of the derivatives. And we have put that into practice a lot, like if we had y equals 3x to the fourth plus 2x, the derivative, so we have a sum here. We just went along and did the derivatives term by term and added them up. So this would be 4 times 3, 12x cubed, plus 2. So the derivative of this sum was the sum of the derivatives. So we're kind of hoping that the derivative of a product is the product of the derivatives. So let's see if we can establish that or not. All right. This is a proof, so write down all the steps and show me them in all their glory on Monday. All right, so let's start with the definition of limit again. It kind of pops in and out of our lives. So the limit as h approaches 0 of the difference quotient. So we're going to have f of x plus h, and that will go into the f function and the g function. Minus the functions divided by h. So the limit of that as h approaches 0 is the definition of the derivative. So what we do is we have a little trick, and the trick goes right here, right where I put that star. So what someone thought of, I don't know who it was, Joel, I don't know, but I'm sure somebody knows. Someone discovered if you replace that in that spot right there, if you put in this expression, negative f of x plus h times g of x plus f of x plus h, g of x, something grand happens. So can I do that algebraically? Yes, because I have a negative and a positive, so they add up to 0. So I won't change the problem at all, but I will give it a boost. So I'm going to go ahead and take a moment and stick that in there. So let's see if I can fit it all in one line. So we have recopying all this until I hit the star, then I'll put in this and go back and finish with this. So you can probably beat me to the punch. Come back, come back. All over. Oops, forgot my 0 as h approaches 0, and we have all that under h. So do you see where I copied this, then I inserted the magic stuff, and that's right here, and then finished with that. Alright, so why did I put in the magic stuff? All right, so let's see the magic unfold. Limit as h approaches 0. The reason they did that is you can factor out of the first two terms something they have in common. So let's pull out what so just looking at the first two. So we have f of x plus h factored out. So what remains? OU and Videoland, can you please tell me what remains? Are you saying loud and clear, g of x plus h minus g of x? And over here in this expression, I'm going to take out a g of x. And when I do that, tell me what remains. Fill it in, speak it, sing it, breathe it. All right, so hopefully you got that. And all that is still over top of h as the limit of h goes to 0. All right, now I'm just going to do a little regrouping. So I'm going to take this h can be divided. We don't know what the we don't know what the derivative of a product is. But we have learned that the limit of a product is the product of the limits. So now that we're using limits, we can break this up into separate limits because this is a product. So the limit of the product is the product of the limits. So I'm going to break it up into the limit as h approaches 0 of f of x plus h times the limit as h approaches 0 of g of, g of x plus h minus g of x over h. So notice I have the h here, I do not have it here, but if I was to multiply these expressions, we would get back to here. So algebraically that's sound to split it up like that. And now you might see where this is happening. So this guy here should be screaming at you that, that looks so familiar. All right, so over here, I'm going to do something similar. I'm going to break that into two limits. So I'm going to go the limit of g of x as h approaches 0. And what am I doing here? Okay, so this is where I'm splitting it up, times the limit g of f of x plus h minus f of x over h. All right, that's got to be screaming to you. All right, so I just did a little regrouping of these terms and divided the product of the limits into the limit. So I took the limit of the product and divided it into the product of individual limits. All right, so now I can't get that whole thing in. I don't know if you can see it if I go back or not. And I always go the wrong way. Come back, come back. All right, so now I can see that what is the limit of this expression as h goes to 0? Well, we just plug the 0 in here and we get the limit. Once we take the limit, we don't have to write that word limit anymore, so it's just f of x. And this is the definition of the derivative of the function g. So we've learned that is our old definition of limits. So you were used to seeing f, but it works with g. And then over here, the limit as h approaches 0. The limit as h approaches 0 of g of x. Well, g of x has no h in it. So it is not affected by h approaching 0. So that limit is just g of x And there's a plus sign, don't forget. When we get over here, this is just g of x, and this expression is the derivative of f. So, what were we looking for? In the very, very beginning, right here, we were looking for the derivative of this product. So let me put that in front again so we don't forget from whence we came. Alright, so the derivative of the product did not turn out like we had hoped. It's a little different, isn't it? So the derivative of the first let's call this the first function and this the second function. So the derivative of the product of two functions is the first function times the derivative of the second plus the second function times the derivative of the first. And that is the derivative of the product, and we call it the product rule. The product rule. So let's go ahead and use the product rule. So say that I have y equals 3x squared sine x. So I have to observe that that is two expressions that are multiplied together. So I have a product. So the derivative is going to be the first expression, unchanged, times the derivative of the second, plus, right there, the second times the derivative of the first. Alright, the only thing your book likes, they love to do this. If you can factor out anything that's common to both terms, they will do it. So you can use your answer key. Let's go ahead and take out, what, a 3 and an x. That gives you x cosine x plus 2 sine x by factoring that out. I don't tend to see a whole lot of sense in that because I factored out if it would simplify things, but if it doesn't, I don't tend to care about factoring it out. But just so you can use your answer key wisely, recognize your answers, go ahead and factor it. Alright, that is the product rule in all its glory, so bring that with you and in your mind and in your comp books on Monday, and that will be seen in your work that day. I hope your weekend is going well. Bye.